So it's teacher Cora, and I'm so excited to be talking with you today for our first official lower school science video. I'm so happy to do a little bit of a review on this. I think it'll be really good, hopefully a good way to jog your memory. Yeah, I will say I miss you guys a lot, and I'm really sad that we haven't had a chance to do science in a while. So hopefully today will be a really fun, good way for you to review, and also hopefully I'll give you a good fun experiment that you can try at home if you are really missing school a lot. Okay, so let's go ahead and jump in and get started about our scientific method, which we'll be talking about today, and a little bit why it matters. Okay, so I tell you guys this all the time in class, but first off, the scientific method is super important for experiments that we do within our science class. So for example, our scientific method helps you know what materials you need, what steps you should take, what kind of question you're asking, what did we figure out from an experiment. Okay, we'll also talk about this on our next slide, but the scientific method matters a lot for competencies. So in order to go on to upper school, you have to know how to do this. Also just for developing skills. So as future scientists of the world, or scientists right now, the scientific method is a really good way to keep your method straight, so kind of what you're doing in practice, and also whenever you go to university, if you're taking a biology class, a chemistry class, any research class, you will also be doing something very similar to the scientific method, if not the scientific method itself. So this is super important for you just to know how to do this, okay? So let's do a little bit of review here. Just to go off the competency that we're going to be studying today. So conduct a simple self-directed scientific experiment without teacher assistance, fill in a lab report using scientific method sections, conduct good observations, be safe, be clean, and measure as needed using these tools. So here is our 7th grade competency, but for 8th grade, of course, you have to know how to do this as well. And today we're going to be doing this in the context of our own experiment. This is actually a great way for you to practice. Could you actually do a scientific experiment by yourself without teacher assistance, someone telling you what to do? Could you follow along and understand the scientific method? All right, so I hope that this will be an awesome practice for you guys today. Okay? All right, so for your do now, I want you to go ahead and pause the video for just a few seconds and see if you can think about the steps to the scientific method. So I'll give you a hint. We have 6 of these. You should all know them since we went over them in class a bunch. But as it has been a few weeks, I'll give you a little bit of a chance to review. So go ahead and pause the video here and then resume whenever you're ready. Okay, so our first question. So first you have to think about, why are we doing this experiment? Or what is the purpose? What are we trying to figure out? Next, hypothesis. So what do we think will happen in our experiment? Materials, what will we use? Procedure, what are our steps? Results, what did we see happen in the experiment? What observations did we make? And conclusion, what do these results mean? All right, so here are our steps: question, hypothesis, materials, procedure, results, conclusion. Make sure you know these. This is super, super important. Okay, so let's go ahead and first talk about lab safety, of course, because we love lab safety. So remember to conduct all experiments safely and responsibly with adult supervision. So normally for at school, you have to do a science experiment with a teacher present. You're obviously not at school, so we can't do experiments together. At home, you need to have an adult with you when you're doing this, all right? Also, be responsible, #1 rule in science lab, and never work alone. Also, make sure you dress properly. So remember, closed-toed shoes, goggles, no loose clothing, gloves. So for this experiment, I will say we're not working with fire or dangerous chemicals. So you actually are okay to not use goggles or gloves, but you just have to be very careful. Remember, in our science lab, this is one of our important rules. Also, if you have an accident or fire, get help immediately from the adult that's supervising you. And of course, do not eat, drink, or chew gum in the lab. All right, so a little bit of lab safety review. Over here, our scientist looks good to go. Okay, so today we are going to be doing a little bit of practice as scientists, and not only scientists, but also engineers. So engineers build things, they make things better. Somaliland has a lot of great engineers. They probably need some more ones. So today I have a project for you as an engineer. I want you to build a boat for me. So I want you to build me a very strong boat. And not only do I want a very strong boat, I want a boat that can carry the most people. So for example, let's say we had people that wanted to go from Berbera to maybe Dubai, by a boat, how would they get there? Maybe we need to fit a lot of people, so maybe we want to save money, we want to fit as many people on this boat. The president comes to you and he says, build a boat for me, can you do it? So today, maybe if you're trying to brainstorm, you're trying to think about how to build this boat, you don't necessarily have a lot of the expensive materials you need, right? So maybe in order to build a boat, you're going to need a lot of wood, maybe you're going to need a lot of metal, it's probably going to cost like thousands of dollars at least. Maybe you're going to need a lot of people to test it out, so it's going to be a very big, expensive project, right? So first you need to think of ideas. You need to do some smaller tests before you get started. So that's a little bit of what we are going to do today. So we're going to go ahead and do a little bit of practice, test some things out on a smaller scale before you could do a large scale project like this. Okay, so if you want, you can go ahead and pause the video now and think about what would be a good way I could test out this experiment without building an actual boat and having hundreds of people for me. Okay? All right, so let's think of our question that we are going to do today. So what I would suggest in terms of how we could test this out, thinking about how we could build a boat, is to do on a smaller scale. So maybe we can't build an actual boat, but maybe we could make something even smaller. So for example, maybe we could think about which one would hold more rice. Maybe we would start with the shape, right? So maybe we say, okay, so we want to hold a lot of people in this boat. Maybe we should think about the shape and how we're going to do it. So what I would say is you can go ahead and start out with maybe 2 boats. So 2 little miniature boats that I've made out of aluminum foil. You say, all right, which shape is better? A circle shape or a rectangular shape? And since we don't have hundreds of people available to you, what we are going to do is today we are going to use little rice people. So 1 grain of rice, 1 person, so that way we can figure out which boat will be able to hold more people. Okay, so not quite the same as an actual boat, but a little bit better on a smaller scale. Okay, so here's our question, why we're doing our experiment. Then we can do our hypothesis. So you say, if I make a circular foil boat, then it will hold more rice or people than if I make a rectangular foil boat because it will be more evenly shaped. So we see here on the circle, our width and our height are exactly the same, right? Whereas on a rectangle, it's a little bit different. So it's not as wide, but it's pretty tall. So what I'm saying is on the water, maybe it's a little bit better to have it be more equal on the sides so that way it can fit more people. So if I'm making a boat, maybe it's better to make a circular one when I start building it rather than a rectangular one. So we will see, this is my hypothesis. You're more than welcome to write your own hypothesis, and that might be something we do as a homework, of course, but to test this out. Remember, a hypothesis does 3 things. It is written very specifically. So it's not a question. It's written as an if, then, because statement. You all know this. Also, it makes a measurable prediction. So could we see actual results in real life? So I'm saying a circular boat will hold more rice than a rectangular boat. I can test this out, right? I can just go put rice in the boat and see which one has more. So it has to be something that you can observe or measure. It's very important. Also, it fits existing observations. So if I said something like, if I added rice to this, then it would turn purple. That's probably not going to happen because rice doesn't typically turn purple, right? Or if you said something like, if I add water to a plant, then it will grow wings and fly away. Probably also not happen. That's not typically what we see happen in real life or in science. So make sure whenever you're writing a hypothesis, it's written if then because, it's something you can measure, and it fits existing observations. Okay? Here we have our materials. So what you can do is go ahead and get started just with 2 equal sized pieces of aluminum foil. So I made mine 5 centimeters by 5 centimeters. You can make them however you want. If you are going to make them, but they just have to be the same size, okay? And what I would say is probably don't make them too big or else it might not work as well with the aluminum foil. Remember, aluminum foil is something that we use in our science classroom a lot, so hopefully you have some of this at home. It's not too difficult to find, okay? If you don't, you can always test out with a different material. You can go ahead and get scissors and a ruler just to cut these and make them the same size. You're going to need a little bit of water, maybe a measuring cup in order to pour this water. So maybe I would suggest like 1-2 cups water. It doesn't have to be that much, but it doesn't really matter. And lastly, 1 clear glass or container, which we'll put our water in. This will be our mini ocean. And maybe a calculator for a little bit of fun math that we're going to do a little bit later on. Okay, so all of our materials, and we should be good to go. Okay, so for our procedure, so here what you can do is if you want, once I put all the steps up, you can go ahead and test it out for yourself, or you can follow along with me. Okay, so we have our question, hypothesis, materials, and now step 4, procedure, our steps on what to do. So step 1, cut and measure 2 squares of aluminum foil. I have 2 exactly the same squares, 5 centimeters by 5 centimeters. I am ready to go. Step 2, make 2 foil boats, 1 circular and 1 rectangular. So 1 circle boat, 1 rectangle boat. I am good to go. We'll figure out which shape is better for holding people. Next, fill a clear container with 1 cup water, or mine is probably closer to like 2 cups water, or maybe a cup and a half. That's okay. So here I've got my ocean, because obviously boats are not on land. We need an ocean to test it out. Next, we will go ahead, step 4, put our circular foil boat on the water. Okay, so it's in there, it's floating, that's great. And next, slowly add pieces of rice to the boat. So here I have many different little pieces of rice. Each piece of rice is equal to 1 person. So I'm gonna go ahead and add it in, just slowly. 1, 2, 3, 4, the double one, 5, 6, 7, 8, and so on. Okay, so remember each piece of rice is going to be 1 person. Now I will give you a hint. It's going to hold a lot more than 8 people. All right, and it doesn't really matter for this if they're like side by side or if they're like on top of each other. It's just for testing it out in terms of weight. Okay, so we're going to slowly add pieces of rice to the boat. Now I am only going to stop once my boat begins to sink because it's too heavy, or if it cannot hold any more pieces. So let's say it's like completely overflowing, there is no more room for people, then you are going to stop and write down how many pieces of rice that it held. Okay, so if this held 25 pieces of rice, then I write down, okay, circular boat, 25 pieces of rice. Okay, so once you finish with the circular boat, what you're going to do is you're going to take it out, empty out any rice, and then you're going to put in your rectangular boat. So here with our rectangular boat, we're going to do the same thing. Again, with our pieces of rice, and you can just add them in, like maybe 1, 2, 3, 4, and so on. Okay, so once you finish with the rectangular boat and either it sinks or it cannot hold any more, then you are going to stop. You are going to record how many pieces of rice it held, and then take it out, empty out your boat. Now there is one more step that we are going to do. So currently we could compare the circular and the rectangular, but remember, maybe sometimes you just messed up. Maybe you put the rice in pretty fast. Maybe you accidentally hit the boat. Maybe you made a mistake. So what we're going to do is we're actually going to measure each boat 2 more times and then take our average. Okay, so it's kind of like the same thing. Like if you were growing like just one plant and another plant and you were comparing maybe like sunlight or water, and then you like knocked over a plant or one plant just happened to get sick, it wouldn't really give you a good result. And so we want to go ahead and test a couple times just so we're absolutely sure that we're correct. Okay, so do 2 more trials of each boat. So circular, add more pieces, do it again. And then also rectangular, add more pieces, do it again. Okay, recording your data as you go. Once we finish our procedure, we are going to go ahead and go to our results. So for our results, we're asking this question: how many pieces did each boat hold? So we see our circular foil boat held 102 pieces the first time. I made a very strong boat, it's very strong. 114 the second time, 108 the third time. Rectangular, 88, 82, 94. So if we're looking at these, we say which one held more? Our circular one did, okay? So what we're gonna do is we need to go ahead and take the average, or kind of the main idea of kind of what was the main number that would be in the middle of all of these. So in order to calculate average, and here's where our math comes in, you're going to add up test 1, test 2, and test 3 for the circular ones and divide by the total number of tests. So we have 3 numbers, so 102 plus 114 plus 108 divided by 3, and get our average. So on average, our circular boat held 108 pieces of rice, and do the same with our rectangular boat, and we'll get our average for 88. So I put this formula at the bottom so you can calculate your own averages, all right? Lastly, we will go to a conclusion. Remember, a conclusion has three parts in it. All right, so part one, what we did in the experiment. Part two, whether our hypothesis was right or wrong, and why, and then also for next time. Okay? So here, for our conclusion, we could say, in this experiment, we were looking to see if an aluminum foil boat would hold more pieces of rice if it was circular or rectangular. Our hypothesis was correct because we saw that the circular boat on average held 108 pieces of rice, while the rectangular boat on average held 88 pieces of rice. Next time, we should try to use a different material like plastic, foam, or even wood like a real boat to see what happens. Okay? So here what we did in the experiment, whether hypothesis was correct or not correct, and also why, how did we see that, how do we know, and what we should do next time. So in conclusion, if we're building a boat, we should probably make it circular if we want to hold the most amount of people. So maybe it won't be the fastest boat, maybe it won't be the strongest boat, but in terms of holding the most people, circular boat is the way to go. Okay, also just to touch on variables very quickly, teacher Hannah also has an awesome video if you guys want to review. Remember, independent, what the scientist changes directly, dependent, what changes as a result, and control, what is kept the same. So if you want, you can pause the video here and think for a little bit, what were our variables in our experiment? Okay? To go over our answers, we say our independent variable was the shape of the boat, whether it was circular or rectangular, so that's what I changed in between our two boats. We said our dependent variable was what changed as a result, so how many pieces of rice the boat held. Control, what was kept the same. So we kept the foil the same, used the same type, we did the same size of the square, we also had the same water, the same container, we did the experiment in the same location, so the same temperature, the same wind, the same environment. We also had the rice the same and we added it in probably, hopefully the same way, not all super strongly or super carefully. Okay, so anyway, great luck, great job today. Good luck building your awesome boat for the president. And yeah, good luck studying tonight. Thank you guys. Bye.